Hi student, today I am going to discussing about circular motion. So before going to discussing about circular motion, first we have to know some basic points. Consider a particle that is in circular motion in a circle of radius r. When particle moves from A to B at the same time the radius, that means here radial vector, radial vector shifted from A to B. That means I am taking the center is O. When particle shifted from A to B, at the same time the radial vector shifted from OA to OB. So the angle made by the radial vector with respect to the position of the particle, that is called as the angular displacement. Units for the angular displacement, now we have the units, that is radians. At the same time, when particle in circular motion, the angular displacement changes from point to point. That means with respect to time, there will be some change in angular displacement. That is called angular velocity. Omega equal to dt, d theta by dt. Angular velocity, or it is also called as the angular frequency. Units now for this angular velocity we can write as here radians per second. When particle is in circular motion, there will be some acceleration. So the rate of change of angular velocity, that is called angular acceleration. That is denoted by alpha. Units for this we can write as here radians per second square. Angular acceleration, angular velocity. What is the relation between the linear velocity and the angular velocity? That means particle travel from or moving in circular path with velocity v. When it is shifted from A to B, it covers a small distance on a linear distance dx. So from this we can write as here dx is equal to, for this shape now, this is the cone shape, the length of the arc is equal to radius into angle. Now for small dx I am taking here angle is d theta. Angular displacement, linear displacement, the relation between them. Differentiation with respect to time, you got here dx by dt is equal to r into d theta by dt. That means dx by dt is nothing but change in velocity, change in displacement with respect to time, that is linear velocity. Here change in angular displacement with respect to time, that means angular velocity. You got the relation v equal r omega. Again differentiate with respect to time, you got here dv by dt, that means acceleration, that equal r into d omega by dt, that is angular acceleration. Linear acceleration, angular acceleration. So just you have to remember these formulas now. Okay, I am going to discussing about the what is the uniform circular motion and non-uniform circular motion. So in circular motion, now we have the two types, that is uniform circular motion and non-uniform circular motion. So what is meaning of the uniform circular motion means now the speed, I am not saying velocity, the speed of the particle is constant. When body traveling in the circular motion, its speed remains constant, but direction changes. So its direction changes from point to point. For example, when particle is at this position, the particle direction, the speed or the velocity direction is like this. Tangent. The tangent at that point gives the direction of the particle. For example, particle is at this point. So in this case, what is direction? The tangent at that point gives the direction. Here speed constant, that means magnitude remains constant, but direction of the particle changes from point to point. That's why there will be some body gains the some acceleration. So due to the change in direction of the particle, the body gains some acceleration, that is called as the centripetal acceleration. So the centripetal acceleration can be calculated, that is v square by r. We know clearly the force acting on the particle is here centripetal force, that is centripetal force according to Newton's second we can write as here F equal to ma. Centripetal force we can write now here mv square by r. Here m get cancelled, from that a is equal to, you got here v square by r. So due to the change in direction of the particle, you got the some acceleration, that is called centripetal acceleration. That is formula AC equal to V square by R. And V is the linear velocity and R is the radius of the circular path. So you know clearly V equal to R omega. Here substitute here R omega, you got R square omega square by R. So in R square, one R is cancelled. Finally what you get now here? R square omega. So R square omega square by R. Here R cancelled. Finally what you got now here? R omega square. Centripetal acceleration in terms of linear velocity, in terms of angular velocity. So that is the centripetal acceleration. So next, Nana, here the centripetal acceleration is always acting toward the center, Nana. When body is in circular motion, its speed remains constant. That means, Nana, at point A, the speed of the particle I am taking as here 10 meter per second. At this point, the speed of the particle also 10 meter per second. Here also the speed of the particle, Nana. The speed of the particle I am taking as here also speed of the particle 10 meter per second. That means magnitude remains constant but direction changes. Due to the change in direction, it got the some acceleration, that is centripetal acceleration. That is always acting toward the center, Nana. The centripetal acceleration acting towards the center. So this type of motion is called as the uniform motion. For example, what about non-uniform motion? The magnitude and direction both are changes. For example, here V equal 10 meter per second. At this point, the speed of the particle 12 meter per second. Here magnitude of the particle, velocity of the magnitude or the speed. The magnitude changes, at the same time direction also changes. That type of motion is called here non-uniform circular motion. In non-uniform circular motion, body having the two types of accelerations. That is here centripetal acceleration due to the change in direction. Due to the change in magnitude, it causes some acceleration that is called tangential acceleration. Centripetal acceleration and tangential acceleration. Here the centripetal acceleration always acting toward the center. The tangential acceleration is acting along the tangent. For example, at this point, centripetal and tangential acceleration. At this point, centripetal is always acting towards the center. This is the tangential acceleration. That means, Rana, these two are always perpendicular to each other. That's why what is the total acceleration or what is the net acceleration of the particle in non-uniform circular motion. So you got here, according to parallelogram law of vectors, we know clearly the resultant vector is given by root of AC square plus AD square plus 2AC AT cos 90. Cos 90 0, that's why this term becomes 0 here. You got the only net acceleration root AC square plus AT square. We know clearly centripetal acceleration, we can write like this. What about tangential acceleration? So the tangential acceleration, that is due to the change of the magnitude. So tangential acceleration, we can write the formula dv by dt. So that equal we can write as here d by dt. In place of u, we can write as here r omega. Take out r common because radius is constant here at any position. So d omega by dt. d omega by dt means rate of change of angular velocity. That is called angular acceleration or alpha. So finally you got here tangential acceleration AT is equal to r alpha. Centripetal acceleration AC equal to r omega square. So the net acceleration or the acceleration of the particle when it performs the non-uniform circular motion. This is the formula for net acceleration. Substitute here AC means we can write as here root of AC means v square by r whole square plus AT means we can write as here r alpha whole square. That is the magnitude of the net acceleration. What is the direction of the net acceleration? Here centripetal acting toward the center, tangential acting along the tangent. But what about the direction of the net acceleration? So for example, according to parallelogram law of vectors, the net acceleration is like this, diagonal. So I am taking here what is the direction of the net acceleration. That means I am taking now here angle phi. by choosing this triangle now, you can take as here tan phi is equal to, I am saying like this. So this is the circular motion now, you can take as here. This is the centripetal acceleration AC and this is the tangential acceleration AT. The net acceleration you can take as here A net. For example, I am taking the angle here or here as you wish. Ikkada angle తీసుకుంటే, so it just construct a triangle, right angle triangle like this. So in this case we can write as here tan phi is equal to opposite by adjacent. So opposite means this one, adjacent means this one. So tan phi is equal to, you can write as here AD by AC. What about AD? R alpha. What about AC? R omega square as your wish. Then you got the phi value. For example, when you are taking phi here, in that case from this triangle, tan phi is equal to opposite by adjacent, AC by AT. Better to take angle here nana. So that is the basic concept by taking the angle here, because the resultant makes an angle with the horizontal. So tan phi is equal to AT by AC. So in the uniform circular motion we have the only centripetal acceleration. The non-uniform circular motion, both centripetal acceleration and tangential both are present. That's why net acceleration, its magnitude and the direction. Direction means angle here. Phi is equal to tan inverse of AT by AC. So that is the magnitude and the direction. Now I am going to solve some problems with respect to the circular motion, either uniform or non-uniform. See, just one problem is there. A point on the rim, a wheel 3 meters in a diameter has linear velocity 80 meters per second. The angular velocity of the wheel. So here wheel the diameter of the wheel is here given. What is the value 3 meters. Diameter is 3 meters from here to here. That means radius we can write as here 3 by 2 meters radius. And the wheel is rotating with linear velocity. V is equal to 80 meters per second. What is the angular velocity? That is our question Here options also given. First option is 4. Second option is 12. And the third option is here 6. And the fourth option is here 18 radians per second. Radians per second. Wheel is rotating with linear velocity 18 meters per second and the diameter of the wheel is 3 meters. From that radius we can write 3 by 2. What is angular velocity? We know the relation between the linear velocity and angular velocity. What is that formula? V is equal to R omega. So from that V equal to 18 R means here 3 by 2 into omega. So 3 1 ja 3 6 ja. Cross product. You got here omega is equal to 12 radians per second. Next one more problem A car is moving with speed of 30 meters per second on a circular path of radius 500 meters. So this is the circular path. A vehicle or a particle as your wish that is moving with linear velocity 30 meters per second. V is equal to 30 meters per second in a circular path of radius R is equal to given 500 meters. So next the speed of car is increasing at the rate of 2 meters per second square. The speed of the car increasing at the rate dv by dt, that is given here 2 meters per second square. dv by dt is nothing but tangential acceleration. Indirectly here the motion of this body is non-uniform circular motion. So tangential acceleration AT is equal to, you got here 2 meters per second square. Now find the net acceleration. What is the net acceleration of this body? So first option 3.6. Here first option 3.6 meter per second square. Second option 2.7 meter per second square. Third option 1.8 meter per second square. And fourth option 2 meter per second square. The problem is that a car is moving in a circular path of radius 500 meters with linear velocity 30 meters per second. Its speed changes at the rate of 2 meters per second square. Then what is the net acceleration? Here when car is moving in a circular path, the direction changes from point to point. That's why it has the some centripetal acceleration. And at the same time here velocity also changes. That's why it has the some tangential acceleration. So what about centripetal acceleration? Here AC is equal to another formula V square by R. So from that what is the V value? 30 square means 30 into 30 by 500. So from that what you get here? 0 zeros cancelled with which are 9 by 5. 9 by 5 means now we got here 1.8 meter per second square. That is the centripetal acceleration. And what about tangential? 2 meter per second square. So what is the net acceleration? We know the formula. Net acceleration is equal to root of AC square plus AD square. So that equal to root AC 1.8 whole square plus AD 2 whole square. So root 1.8 whole square. 18 is 324. A point is there. So you can write now here 3.24 plus 2 square means 4. 4 plus 3 7. Root 7.24. Nearly now for example root 625. Root 625 means 25. Here root 724. That means that value is more than 25 nana. That means 26. But here 7.24 nana. That's why nearly what you get here 2.7. That is our answer nana. Nearly. So 7.24. If 625 is there, you got the 25. 6.25 means nana, you got the 2.5. Here 7.24. That means more than 625. That's why you got nearly nana 2.7. So that is the one more problem. And here one more problem is there nana. The speed of the angular frequency of the fan increases from, so it is in rotatory motion, no problem. And one more problem, two stones of masses m and 2m are drilled in the horizontal circles, the heavier one in the radius r by 2 and the lighter one in radius r. So what is the data here? Heavier and lighter, two particles are given now. So one particle connected with a thread, mass m, now that is rotated like this in horizontal direction, horizontal circle. So with the velocity v1, mass m1, I am taking here m1 is equal to m, light thread nana. The radius of the circular path is r1. And one more body nana, that mass is m2, I am taking as here 2m in the given problem nana. Radius of this path I am taking as here r2. And it is moving with velocity v2. So just listen nana. Two stones of masses m and 2m are drilled in horizontal circles. The heavier one in the radius of r by 2. And r2 is equal to given nana r by 2. And the lighter one in the radius of r. Lighter particle in the radius of r. The tangential speed of the lighter stone is n times of that of the heavier stone. That means in the from the problem, the speed of this lighter particle is equal to n times of the speed of the heavier particle. What is the speed of the heavier particle? I am taking as here v2. That's why v1 is equal to n into v2. Okay. When they express the same centripetal force, the value of n is. What is our condition, Anna? Here the two particles execute the or experiences the same centrifugal force. Then what? Same centripetal force. Then what is the n value? We know centripetal force. Formula what is Anna? F is equal to mv square by r. From the problem, the centripetal force acting on the lighter particle is equal to the heavier particle. So by using the formula, you can write as here m1 v1 square by r1 is equal to m2 v2 square by r2. Substitute here m1 m v1 means I am writing on a n v2 here, n v2 whole square by r1 means on here r, that is equal to m2 to m v2 square. I am writing v2 square only nana by r2 means here r by 2. So here M cancel, and here R send above nana, these two send above, you got here 4. Here R cancel. That means you got here n square, this is value nana, v2 square is equal to 4 v2 square. Here v2 square get cancelled, n square equal to 4, n is equal to 2. So that is the problem nana. Our options is here 1, first option is 1, second option is 2, third option is 3, fourth option is 4. Once again, two particles, they are connected with the thread and rotating in horizontal direction nana. So the speed of the first particle is n times of the speed of the heavier particle. Radius of the first particle r. Radius of the circular path, sorry, not radius of the particle, the radius of the circular path, that is r, here r by 2. The two particles executes the r experiences the same centrifugal force. Then what is the value of n? You got nana, n is equal to 2. Here n square is equal to 4, n is equal to 2. So our option is second option nana. So in the options, first option is 1, second option is 2, third option is 3, fourth option is 4. So our option is second option. And one more problem is there nana. A particle P is in circular path. Find the ratio of the angular velocities of the particles when it is, just wait nana. A particle is in circular path with velocity v. In a radius of the path is r. AB is the diameter of the circle and C is the center. The angular velocity of P about point A and C. Here a particle is in circular motion, or that is moving with some linear velocity v. When it is at point P, the velocity of the particle is given on v. Diameter of this circular path it is given here A, B. Center of this circle C. Radius of the circular path R. Now what is the angular velocity of this particle with respect to C and with respect to A? That is our question nana. What is the ratio of the angular velocity of the particle with respect to point A and with respect to point C? That is about. So I am taking when particle at point P about this C, it makes some angle. The angular displacement I am taking as here alpha. That means the angular velocity of the particle about C is equal to, angular velocity means rate of change of angular displacement. That means here we can write as here alpha by t. Displacement by time, angular displacement by time The same way, the angular velocity of the particle about the point A. So in this case here it makes some angle beta. I am taking as here beta. That's why the angular velocity of the particle about the point A, we can write as here beta by t. Ratio between them, you got here this one by this one t cancel. So omega c by omega a is equal to alpha by beta. But in our options 1:1, 1:2, 2:1, 4:1. First option given here 1:1, second option 1:2, third option 2:1, fourth option 4:1. But here we got alpha by beta. So from this diagram, when you are saying this is beta, it is also becomes beta From center to, this is the radius, here also radius, it is the chord that's why you got here beta beta. So from this triangle, these two are the interior angles, it is the external angle So sum of the interior angles is equal to exterior angle. That's why from this figure we can write as here 2 beta is equal to alpha. Now substitute here. That equal in place of alpha you can write as here 2 beta by beta. Beta beta cancel. From that what you get now here 2:1. So that is the answer 2:1. So that is one more problem about the circular motion. And one more is there, Nana. A particle moves on a circle of radius r with a centripetal acceleration as a function of time AC is equal to. Given, Nana, one more problem. A particle moves on a circle of radius r. Particle moves on a circle of radius r. Okay. With some centripetal acceleration, AC is equal to k square or t square. It is as a function of time. Where k is positive constant, find the net acceleration. Here asking, Nana, net acceleration. That means a net. That equal to the formula under root AC square plus AT square. In the given data, AC is there. But what about AT? We know AT means, Nana, change in velocity with respect to time. We know the formula here clearly. AC means, Nana, what is the formula? V square by R. That is equal to K square R T square. So from this, V square is equal to K square R square T square. From that, V is equal to K R T. Velocity, linear velocity of the particle. I am going to calculate the tangential acceleration, Nana. We know the tangential acceleration is nothing but dv by dt. Differentiation this one. So d by dt of, we can take as here k r t. So from that, k into r take out, you got here d by dt of dt. This one cancel. Finally, what you get, Nana? Tangential acceleration is equal to kr. Centripetal acceleration already given in the data. What is the net acceleration? We know the formula for net acceleration. Substitute here. That equal to root AC square. That means k square r t square whole square plus AT square. That means, k r whole square. Now here that equal to under root k power 4 r square t power 4 plus k square r square. So from this k square r square take out. K square r square take out, Nana. From here k square under t power 4 plus 1 is there. Root is there, Nana. K square r square take out. You got here k r root k square t power 4 plus 1. So that is the answer, Nana. That's net acceleration of the particle in circular motion which has the centripetal force as the function of time, that is AC equal to k square r t square. E particle to net acceleration enta ante we know the formula. AC is there but AD is not there. AD can be calculated with the help of this value, Nana. AC means we know the V square by R. So V square by R equal to this one. From that, what you get here? V. From this V, you can calculate now tangential acceleration, that is AT. So from that, AT equal to KR. Now substitute here, you got the on simplification, you got this value. So your answer is the fourth option is there. Sorry, third option is there. KR root K square t power 4 plus 1. So that is about the circular motion, uniform and non-uniform. The uniform circular motion, speed constant, but direction changes. Due to the direction changes, it gains the some acceleration, that is called as the centripetal acceleration. The formula for centripetal acceleration, AC is equal to V square by R. In non-uniform circular motion means speed and direction both are changes, and magnitude of the velocity and direction both are changes. That is called non-uniform circular motion. Due to the change in magnitude, it got the some acceleration, that is tangential acceleration dv by dt. Change in direction, you got some acceleration, that is centripetal. That's why we have the two. In non-uniform circular motion, particle has tangential and also centripetal. What is the total acceleration? Root of AC square plus AT square. Direction formula tan phi is equal to AC by AT. So problems already we did it. సో ఇది కాన్సెప్ట్ నాన్న, కొంచెం జాగ్రత్తగా మళ్ళీ మీరు ఒక 2-3 ప్రాబ్లమ్స్ సాల్వ్ చేసుకుంటే చాలు. అందుకు ఇంపార్టెంట్ కాన్సెప్ట్ నాన్న. థ్యాంక్ యూ, బాయ్.